Problem number 3 asks us to determine the net torque of the two forces about the origin, counterclockwise positive. So we are given, again, a coordinate system. Here's the origin right here. We're given two forces. Let's highlight those. This 60-pound force at 30 degrees and this 40-pound force that's going vertically upward. Okay, remember torque is force times perpendicular distance. Alright, so we've worked this several ways. To me, the easiest way is to break everything into components. Alright, so location is important when you break into components and dealing with torque. So I'm going to draw the components this way. Okay, so this 60-pound force has a horizontal component to the right and a vertical component downward. The vertical component would be 60 times the sine of 30, and the horizontal component would be 60 times the cosine of 30. And we'll factor in the direction when we look at the torque equation. Okay, so if I see a problem like that, that's probably the first thing I'm going to do. Alright, so we have to remember that we're taking the torque about this origin point, and so this 40-pound force is going to have a perpendicular distance of 3 feet. This vertical component of the 60-pound force is going to have a perpendicular distance of 2 feet, and this horizontal component will use the vertical distance, or 4 feet. And we have to factor in the directions as well. So let's go ahead and write out our equation. Okay, the torque is going to be the sum of all the torques. Okay, so let's work with the 40-pound force first. So we're going to have 3 parts to it. 40 pounds is the force. Perpendicular distance is 3 feet. Okay, and this is going to cause a counterclockwise rotation. If I imagine rotating about this point, come around, that's counterclockwise. Okay, we say counterclockwise is positive. So for each force, or each force component, I'm going to make sure to factor in the sign. Okay, so I'll just write it like that to remind myself that I've thought about whether it's positive or negative. Okay, I'll erase this just to get it out of the way a little bit. Let's look at this vertical component of the 60-pound force. So down here we're adding these together. So we'll have 60 sine 30. Okay, its perpendicular distance is this horizontal distance, 2 feet. Okay, this one, so I'm looking at this force right here, trying to imagine it going around that point, is also going to be counterclockwise. So we'll write positive for that as well. Okay, I'm going through this slowly. Hopefully this will explain this to people who are still having trouble with it. So we're adding in the third component of the force. So we're looking at this horizontal component, 60 cosine 30. Its perpendicular distance is the vertical distance of 4 feet. Its direction, okay, if I were to imagine it rotating about this point, it would be clockwise. So, whoops, I said clockwise, negative. Okay, so that's all there is to this problem, is keeping straight the directions, which distances, and the components. So let's plug this in. Okay, so I have positive 40 times 3. The next one's going to be positive 60 times sine of 30 times 2. The next one's going to be negative, minus 60 cosine 30 times 4. Okay, so my final answer is minus 27.8. represented torque with the Greek letter tau, minus 27.8. Its units, I forgot to write units in here, but that's pounds, and feet. Okay. So the negative tells us that it's opposite the direction we assume positive. Okay, so we could either write minus 27 pound-feet, okay, because we've specified a positive direction, or we could write 27.8 pound-feet clockwise. So either answer would be perfectly acceptable. Okay. To me, this one's a little bit clearer because you don't have to go back and reference the given positive direction.